Hi, my name's Steve. I'm from Microscopy Supplies Australia, and I'd like to introduce you to our new atom probe holder. I say atom probe holder, but it's also compatible with Joule TEMs as well as FIB-SEMs, and it's also useful for performing transmission Kikuchi diffraction in TEMs. So I want to first talk about the original design and why we've gone to this new design. So the original design consists of two pieces held together by a screw, sort of a clamping mechanism. The first hole is designed to go into the pin of the Joule single tilt holder, and the distance from that hole to where the tips end up being is the same as the distance required so that it's in the center of the TM. Also, the height in Z is around the eccentric height of the TMs. Now, while this worked quite well for a while, we had some handling issues with this screw. It's quite fiddly when you're trying to maneuver a grid into place and clamp it together, and the original grid would sit on the thread of the screw, and so when you tighten it up it would sort of change its rotation as well, which is a little troublesome. So I've made some design changes. Also, the screw and the design of this one is quite a bit bigger, and so that means that our tilt range in the TM was a little limited. So the new design is much narrower, so that it gives us more tilt range in the TM. And also, if we look at the sort of side profile here, you'll notice that it's also much slimmer in general. And so that also combines to give us even more tilt range in the TM and reduces the probability of damaging the TEM by knocking into the objective aperture and stuff, which we had actually done a few times with the screw head, which we often had to shave down a little bit, as well as shaving off the base of the screw. So we also have our new grids here. So the grids themselves have a couple of little features I'd like to mention. So first of all, the two end sort of pieces stick out further than all of the tips, so that gives them some level of protection. There's also, you might be able to see, a tiny little sort of notch on the grid on both sides there. This fits in here up against the flats of the holder, and so self-levels it. So that's very useful for keeping the tips in line with the axis with the atom probe. And the holder itself. There's also a little sort of circular tab in there, which I will show in another video how easy it is to poke that through and get the tab to sit vertically. And that makes it much easier for handling. And so the new holder has a spring that holds the sample in place, and that spring just lifts up as you press it down into the loading block. And it also has a cutout in that spring, so you can still sort of get your tweezers in there and use the tab and manipulate it. So there's no loss in functionality in terms of the new holder. It will still go in all the same instruments. And the spring has made handling the grids much simpler, much easier. So the spring has been tested down to about 20 Kelvin in the atom probe, and it works fine. But for an added sort of security, if you like, there in the new holder, this is one without a spring, and you'll notice that there is firstly a cutout for the grid, and it's a little hard to see, but sort of in the middle at the top there's actually a little raised wedge that is sort of semicircular, and that fits in the slot of the grid when the tab is lifted up. And that little notch helps stop the grid, any possibility of the grid sort of falling out or being ripped out. Because as we get cold, we're going to lose some of our spring tension, and I just wanted to be sure that it would stay in there. So this, like I said, has been tested down to 20 Kelvin, and it was nice and solid and performed fine. So that's our new holder, and I'm hoping you'll all find it useful. Check out the loading block video if you want to see a little bit more on how to manipulate your samples.